Okay. Yes, it started recording. So in today's session, we'll be looking at combination of functions. So then let's do that. They say sums. So the objectives of this module is sums, differences, products, and quotients. We know what a sum is, right? We know what sums are. No, yes, no.
Yes.
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 Yes, ma'am.
Okay. So when you add 2 plus 3, you get 7. 7 is the answer, and the answer is the sum. Whatever you get when you subtract is the difference. Whatever you get when you add is the product, and whatever you get when you divide is the quotient. So then you have the composition of function and the applications of the composition function. So at the end of the day, you need to know all those ones. They will be in the exam. Sum, differences, products, and quotients. They say two functions, f and g, can be combined to form a new function, which is f plus g, f minus g, f times g, and f divided by g, in a manner similar to the way we add, subtract, multiply, and divide real numbers. Right? Now they say, for example, if we define a function as f plus g, and the representation can be this one or that one. We're just necessarily saying that we are adding f of x and g of x. So the new function is called the sum of the functions of f and g, and its values at x is f of x plus g of x. Of course, the sum on the right hand side makes sense if both functions are defined, right? So meaning that this can only make sense if this function and that function are defined. That is, if x belongs to the domain of f and also to the domain of g. Make sense?
Yes.
Okay.
No, ma'am. No, ma'am.
Let's move.
No, ma'am.
Can you
Please
please repeat, ma'am?
So they are saying that the sum of the right hand side, meaning that x, for this thing to be the sum, meaning that f of x plus g of x, for it to be defined, that what's this, the x, okay, so x belongs to both domains, meaning that x has to belong to the domain of f and x has to belong to the domain of g. If it happens that it belongs to the domain of f but it doesn't belong to the domain of g, then the two function, then f of x plus g of x is not defined. That's what they're saying. So meaning x has to be in the domain of f as well as in the domain of g. Makes sense? Does it make sense now?
It does make
Someone is
sense.
not
Yes,
muted.
ma'am.
Someone
Yes,
is
ma'am.
not
Yes, we
muted.
understand.
Can you please mention the person's name?
Sandy the Tolisiwe, ma'am.
Thank you. Sandile.
No, it's Cindy, ma'am.
Sindile. Thank you. Sindile.
Sorry.
Where's Cindy Kolisile? Okay. I'm going to remove you from the meeting, Cindy.
Sorry, ma'am.
Now we'll be removing people from the meeting so that we don't get distracted. Okay. So now they're saying that, okay, now we are okay, right? When it comes to, they're saying that for f of x plus g of x to be defined, x has to be in both domains. Are we all okay there?
Yes, ma'am.
Thank you.
Yes, ma'am.
I don't know what I did now, so okay. There you go. So now they say that, so if the domain of f is A and the domain of G is B, then the domain of f plus G is the intersection of these domains. That is A intersection B. Does it make sense? Guys?
Yes, ma'am. Yes. Does make
Thank
sense.
you. Remember in chapter 1, you look at sets, right? Where you had A is equals to, let's say, 3, 2, 1. And then in B, you had, let's say, 2, 1, and 4. Now, if you go and check the intersection, that means that it is in A and it is also in B. Which number is in A and is in B as well?
It's 2,
Two.
1.
2 and 1,
Yeah.
Yes.
right? So 2 and 1 is in what? Is in A and B as well. So that's the intersection. That is why they said here, of course, the sum on the right hand side makes sense if and only if the values of x in the domain of F are also found in the domain of B. So if this one was the domain of F and if this one was the domain of G, meaning that the values of x in here, these values, for them to, what's this, for F plus G to be defined, the values of x must also be in the values of G as well. So now they are saying, similarly, we can define the difference, the product, as well as the quotient of the function f and g. Now their domains are the intersections. Are we all together there? Are we getting it? They're saying the domains are in the intersection. So if you have a function f of x, and g of x, their domains are the intersection, right? So meaning that for f of x, okay, let me continue. Here's the block. It actually defines it. So they're saying that if you are adding function, the domain is the intersection. If you are subtracting function, then the domain is the intersection. If you are multiplying functions, then the domain is also what? The intersection. But when you are dividing the functions, the domain is the intersection except for what? Except for, okay, I can't see this properly. Discharge. Except for this part where g of x is equal to 0. Are we all together there? Did I lose someone?
Ma'am, I think you made a mistake, ma'am.
Where?
You said g of x is equals to 0, and I think the sign says cannot be equals to 0, ma'am.
Thank you. So the domain, thank you very much. The domain of f of x divided by g of x is the intersection except for the values of x for which g of x is equals to 0. Thank you very much for correcting me there. Does it make sense, guys? Hello?
Yes, ma'am.
No. Yes,
Yes,
ma'am.
So now they're saying that, this is what they're saying. They're saying that, because I had a no. They're saying if you have f plus g, right? You go and find the domain of f, and then you go and find f of x, not f, sorry. You go and find the domain of f of x, and then you go and find the domain of g of x. Let me click here. What's going on? You go and find the domain of f of x, and then find the domain of g of x, and find the intersection of the two domains. Once you get the intersection of the two domains, that is the domain of f of x plus g of x. Does it make sense now?
Yes, ma'am. It makes sense.
Okay.
Yes, ma'am.
Yes,
So now
ma'am.
they're saying that even when you are subtracting, the domain is still the intersection of those domains. Even when you're multiplying, the domain is still the intersection of those domains. And when you're multiplying, when you're dividing the functions, the domain is still the intersection of the domain, but excluding the value of x, for which when you substitute, the denominator is equals to 0. Let me write it here because I cannot see it on my side. I don't know what my screen is doing. Such that this part here it should not be equals to 0, this part here, because we know that division by 0 is undefined. So that's what they're saying. That's what the block is saying. Now they say, okay, fine. Now we have these two functions. Let's take a screenshot. So we're taking a screenshot of that. We have these two functions, and they want us to find f of x plus g of x, f of x minus g of x, f of g, f times g, and then f divided by g, as well as their domains. So that's what we are asked to find. And this is in your assignment, if I remember correctly. And those who have done it, they know it's in the assignment. And those who picked that assignment, looked at it, they also know it's in the assignment. So which one are we starting with? F of x, right? Plus.
Yes.
So they're saying that
Yes.
we want, are we choosing a color this week?
Red.
Red, guys. Okay.
Blue.
Didn't we use red last week?
We did blue.
Can you use
Blue,
other?
ma'am. Blue.
Blue.
Which one?
The dark one.
Okay, let's use blue. Now they want us to find f of x plus g of x, as well as its domain. Remember we said in this module, this is how we write the domain of f of plus g of x. That's what they want us to find. Now, according to that blue block, it says we go and find the domain of f of x. So what is the domain of f of x? Anyone, everyone?
X cannot be 2.
Thank you. We said x is an element of real number such that x minus 2 cannot be equals to 0, meaning that the denominator here cannot be equals to 0. So then this will then give us x such that x cannot be equals to 2. There's no way I'll not ask you to find the domain in the exam. I'm just telling you. Don't say I didn't plug you. Now, what is the domain of g of x?
X is greater than 2, greater than 1,
Sorry.
0. X is
Zero.
greater than 0.
X is
Yeah.
greater or equals to 0.
Okay.
Thank you. So we said that the domain, which is x, such that everything under the square root should be greater or equals to 0. Because if you take the square root of a negative number, then it's undefined. So then x should be greater or equals to 0. So those are the two domains. Now, can someone give me, remember I said to you, we need to have the interval notation, which is what we wrote here, and the, what's this? No, sorry. We need to have the set notation, which is this one because of the curly curves that I didn't write properly, and the interval notation. Can I please have the interval notation for these two domains?
Can I try?
This one, yes, please. This
Okay.
one will be
Oh, x such that x must be greater or equals to 0 and x cannot be equals to 2.
okay. So don't say x such that. That's a set notation.
Oh, that's a set notation, ma'am.
Yeah, you see what we have written. Remember in chapter 1, these, when you had something like this, even in grade 12, you had a set of numbers, So that's a set notation. I want to do the interval notation because in the exam, I normally ask the interval notation.
Oh, the interval also, ma'am. I didn't hear you properly. Okay.
Yes,
You're gonna do square brackets, ma'am,
square bracket.
and 0.
Okay, sorry, I just need to fix here. I want the interval notation for the top part first, this one. So this is equals to, or you wanted to answer this one. So okay, this is equals to square bracket.
Square bracket 0 and comma 2.
Oh, sorry. Yo. I'm sorry. Continue.
0 and 2 and then normal brackets, ma'am.
0 and 2.
Yes, ma'am.
For G of for the domain of G.
For f of x, ma'am.
So for f of x, you are saying 0 and 2, then normal brackets. For the bottom
Yes.
one,
And then you're gonna put union.
what's a union, Gonj? Uppercut. This one.
A,
that the-
a union symbol is like a U, ma'am. Yeah, this
Okay.
one. And then you're gonna put a normal bracket
Mm-hmm.
to an infinite, and then normal bracket, ma'am.
And then the g of x.
The first one, ma'am, is for f of x, and then union, and then the second one is for g of x.
You're saying on this one, the first one is for f of x and the second one is for g of x.
Yes, ma'am. I combine them, ma'am.
Okay, we don't want us to combine them yet. You
Oh, yeah.
understand?
Okay.
I
ma'am.
just want for f of x in the interval notation. How do you represent this in an interval notation?
Are you asking me, ma'am?
Yes, you started, isn't it?
Okay, let me see. On this one, I'm not sure, ma'am.
And please, there are people I know they know because they've you know yourself. Please don't answer. And everyone answers. They know themselves. And I won't say why. Someone else.
Oh, open bracket and then negative infinity.
So open bracket. Ooh, sorry. My ancestors, please don't answer on my behalf of my new students. So it's open bracket, yes?
Negative infinity.
Mm-hmm.
And then 2 open bracket.
Mm-hmm.
And then union
Mm-hmm.
open bracket 2 positive
Mm-hmm.
infinity.
And then g of x.
G of x is just g of x is supposed to be greater than 2, so you can only it's going to be a square bracket 0 positive infinity. You wrote it down.
Yes, that's why I said Asa and I wrote the answer. Okay. Who's confused on these two, on the interval notation, because it will be in the exam?
Me, ma'am.
Ma'am, please
Yes.
explain the first one for f at x.
Oh, okay. But you understand when with set notation, isn't it, where x is not equals to 0? I mean, x is
Yes.
not equals to 2. Forgive me, guys. I'm still on leave, but don't worry. I'll come back small by small. Okay. So normally, if it's like this, you draw a number line, right? Let's do for f. Look at this. You go and draw a number line. Where is 2? 2 is here, isn't it? Are we all together?
Yes.
Yes, ma'am.
Now they are saying that not 2, meaning that it will be open dot.
Yes.
If it's not 2, it means it's everything from the left of 2 and everything from the right of 2, but not 2. Do we agree?
Yes, ma'am.
So how do we represent everything from the left of 2? What is the number? What do we use from these numbers? How do we represent these
Negative
numbers?
infinite.
Well
We
done.
use
And we say
infinity, ma'am.
so there's negative infinity up to.
Up to 2.
2.
Do you see that?
Yes, ma'am.
But we don't include 2 because they said not 2, so we put like that. So we're saying that our function is defined at negative infinity up to 2, or is also defined at what? At 2 up to?
At 2 positive infinity.
Does it make sense now?
Yes. Oh, ma'am, I have a question, ma'am.
Yes.
Will you be penalized if you only write a normal bracket to infinity and then normal brackets only, not negative infinity to 2?
You will be penalized because that option might be in the, remember your exam is multiple choice. So that option might be in the exam and it's the wrong option.
Oh, okay, ma'am.
And if you don't choose the right option, it means you chose the wrong option. Okay, so now that we found the domain of F and we find the domain of G. So they are saying that the domain of F and the domain of G are the intersection of the two. Are we all together, guys? Am I losing someone?
Yeah, we
Yeah.
are good. We are good.
So what is an intersection? Yeah.
Ma'am, I think an intersection is a point whereby two functions meet, ma'am.
Thank you. Simple English. They meet. Now, this one is a union. And the opposite of that one is an intersection. The union says or, the intersection says and. Right? So meaning that when you are intersection, me and you, not me or you, me and you should be in the same place. It's like when we are meeting, intersection means meet. You can't say you met me at Checkers when you were at Pick and Pay. Me and you, we have to be both at Checkers to meet, to intersect. So meaning that the domain of F and that's and G, the intersection, will give us the domain of F plus G. So please help me find the intersection here. How am I going to find the intersection? Do you know how to find the intersection?
Add the two graphs.
Let's add them.
No, like equate them.
We are not finding the point of intersection. Please don't be confused. We're not finding the point of intersection. We are finding the intersection of the domains of the graph, which is different.
Can you please explain for us a bit?
When you find the point of intersection for the graph, let's say you have a parabola like this and a straight line. Point of intersection is where they meet, they cut, right? But now we are not finding those points. We are finding where the domains are intersecting. The domain of a parabola and the domain of a straight line are intersecting, not the point of the intersection of the two graphs.
But ma'am, aren't you supposed to maybe add the graph, then find the domain of the added graphs? I don't understand what you're saying.
Okay, yes. Okay, I started with the domains. It's fine. What I'm trying to say is, isn't that they are saying that we add the graphs, then we find the domain. Now, to find the domain, okay, maybe I started wrongly. Let's add the two graphs then. But we are already here, so should we add the two graphs first?
Yes.
Okay.
Yes.
Let's do that. So we have f of x plus g of x is equals to 1 over x minus 2 plus square root of x. There we have added the graph. So now give me the domain of the of f of x plus g of x. Give me the domain there.
X has to be greater than 0 but not equals to 2.
How did you get that? So you're saying that
X has to be greater than 0 but not equals to 2.
how do I write it?
How do you write it? The same one that Tokozani started with. That one. You wrote it.
Wait.
Ma'am, just change the negative into a square bracket, the negative infinity into a square bracket of 0. Yeah, that's it. In the first one.
In the you want to put the negative infinity?
No, like just change it.
Oh, sorry.
Change it into the square bracket and then add 0.
I can't change the first one because we're not the first one is correct.
No, like for the domain of the added two graphs. That's what I'm saying.
Oh, for the domain of the added two graphs.
Yes.
Okay. So it will be equals to?
Open brackets is 0, square bracket is 0, and then 2 open brackets union, and then open brackets 2, and then positive infinity.
So you say open bracket 0, then 2, then?
Normal bracket, U, and then normal brackets again, 2 to positive infinity. Normal
Is it correct, guys?
Yes, ma'am.
If it's correct, is there someone who still doesn't understand what's going on?
Yes, ma'am.
Yes, ma'am.
Oh, ma'am.
Okay.
I have a
Ma'am,
question.
Yes,
Ma'am,
ma'am.
can I try?
Hi. Okay. Please try.
Oh, ma'am, I have a question, ma'am.
Yes.
I wanted to ask, why did we use the union symbol instead of the intersection? And but the question asks for the intersection of the domains of F and G.
That's why we are trying to get, guys. That's where we are trying to get. That's where we are trying to get. Let's get there first. Let's see what your understanding is first. Let's see what your understanding is first. Okay. Let's do it together, me and you. I need space and a clean place. So I'll say copy. We come here. And listen carefully. These are the two functions, isn't it?
Yes, ma'am.
Okay. The two functions, they want us to find f plus g, and they want us to find the domain of f plus g, right? So let's start with what you guys said, f plus g. We know that f plus g, they might write it like this, f of x, or they might write it as f of x plus g of x is equals to what? Is equals to 1 over x minus 2 plus square root of x. Are we all together there?
Yes,
Yes,
ma'am.
ma'am.
Now they said that in our notes, for the domain, for this to be defined, what we wrote here for it to be defined, the x values in this function here must be in the same x values, must be also in the function g. That is why they are saying that the domain of f plus g must be the intersection of the domain of f plus the domain, must be the intersection of the domain of f and, remember, intersection is and the domain of g. That's what our note is saying. Are you all together? In our notes, they said domain of a and b, because they say a is the domain of f and b is the domain of g. Are we all together there?
Yes, ma'am.
Now, since they are saying that the domain of f plus g must be the intersection of the domain of f plus and the intersection, must be the intersection of the domain of f as well as the domain of g, meaning that we have to go and find the domain of f. So we went and find that the domain of f is equals to the set of x element of real number. You can also write like this if you want, such that here we said x should not be equals to 2. That's what we said. Or you can write it the way in our notation in the textbook says x such that x is not equals to 2. But as I said to you, I want you to be able to write all notations, the interval notation as well as the sort notation. The one you wrote is the set notation. Now I want you to write the interval notation. So how do we do that? If it's not as clear, some people can look at it and say, open brackets 2, square bracket 0, and whatever. If it's not clear to you, what you do is you go and write, you draw a number line, as I said. You go, and 2 is not included, so 2 is here. So meaning that your function, they say all x values, x element of real numbers, meaning that all these x values and all these x values, but not this particular x value. So meaning that you are saying that my function, the domain of f is what? Is from negative infinity. Okay, from negative, let me remove the plastic here for this pen. Negative infinity to 2, but not including 2. Or the function f is defined from what? It's defined from 2 to infinity. Are we all together there?
Yes, ma'am.
Because you're saying the function is defined here or is defined here. We are all together. I need 3 yeses to continue.
Yes, ma'am.
Oh, ma'am.
Yes.
So
Yes,
it would
ma'am.
have
Yes, ma'am.
Yes.
it would have been an intersection had the graph also been like if the graph also touched at 2. So because
So if the graph touched at 2, you were going to include it was. I don't understand. Please repeat.
remember the question was why are we saying union instead of intersection? Because the question said find the intersection between the two or something like that.
No, we're not there yet.
Okay.
Here we are finding what is the domain of f. We're looking at the domain of f here. We're not even close to. Remember that we are saying that the domain of f plus g is the domain of f. Where's the domain of f? It's this one here. Are we all together?
Yes, ma'am.
Maybe I don't know, maybe my brain is on leave. Are we all together? Is someone, maybe I wrote wrong. Remind me. Is the domain
We
of
use
f correct?
Ma'am, we use the union sign because we have not yet combined the domains of the two graphs.
Thank you very much.
In the domain of the f of x.
Thank you. So now we are done with this domain. Is it correct?
Yes, ma'am.
Yes, ma'am.
Yes.
Now let's go
yes.
and find this domain now. Right? So now the domain of G, what is the domain of G? The domain of G, we know that all values under the square root should be what? Should be positive. So it's x element, you can write it like this, x element of a number such that x is greater or equals to 0, or the notation in the textbook, which still says that x is an element of a number such that x is greater or equals to 0. Now I want the notation for this, the interval notation. How do you do that? If you are someone who can see and just write it, then write it. But if you are someone like me who likes drawing, even if I don't know how to draw, you then go and draw and say, okay, fine, from 0. You see here, and 0, they say it's included. So it's from 0 to
infinity.
Greater than, to infinity, meaning it's here. So meaning that this is represented as from including 0 to infinity. Are we all together?
Yes.
All right. Now, we are not done. We just find the domain of f and we find the domain of g. So they're saying the domain of f plus g is the intersection of these two domains, meaning it's the intersection of this domain and the intersection of that domain. Makes sense now?
Yes, ma'am.
How do you
Yes,
give me
ma'am.
the, can you give me the intersection by just looking at it? Yes or no? For me, I'll say no.
No.
Doesn't look easy to me. Someone might just look at it and say, this is the intersection. So what do you do when you can't find the intersection like me by just looking at it? You go and draw a number line. Now you're drawing both domains on the same number line. That's what you're going to do. So what you're going to do is you go and draw your domain, your number line. So this is my number line. Do you see that? Ne? That's my number line. And then I want from x, from negative infinity to 2 and whatever, this one. Do you see that? Then I go draw. At 2, am I putting an open circle or a closed circle at 2?
Open circle.
An open circle.
Open circle.
Open. Then I go and say, okay, they are saying that all the values of x element of real number, meaning all the values of x. It means from negative infinity, then I skip and I come to positive infinity. That's the first domain. Then I'm done with this domain. Are we all together?
Yes, ma'am.
Yes, ma'am.
Then I go and draw the second domain. So I'll choose red or choose blue in this case. Right? Now, the second domain says 0, greater than 0. So I go and 0. Where is 0? Should I put 0 after 2 or before 2?
Before two.
Before 2,
So
ma'am.
so I go and put 0 here. Right? And then it says from 0 to where?
To positive infinity.
Positive infinity.
To the right.
Do you see that? So now, how do I find the intersection? I said that for us to meet, intersect means to meet. It means that we focus on the points where the two drawings are meeting. In this case, we focus on the points where the two highlighters are meeting, the yellow and the blue to form a green. Does it make sense?
Yes, ma'am.
This is the intersection, which is this one over here. This intersection. This one over here. So then where do these colors meet?
Between 0 and 2.
0 to infinity.
To infinity.
0 and 2.
Between?
Between
0
0
and
and
Between
infinity.
0 and 2.
Why are you saying 0 to
From
infinity,
0 to
guys?
infinity.
Eh? Why are you saying 0 to infinity?
That's where we see the
No.
green color. Oh, it's from 0 to 2 and then from
2
2
to
to
infinity.
infinity.
Guys, if you are just like me and you want to see things when you are drawing, use highlighters. I used highlighters up to grade 12 in maths. So look at it. Just look at it. Just look at it. You can see that from 0 to 2, I see green. So it's from, I don't know why the pen is not writing. Who's doing magic that side, guys? The pen is no longer writing. So it's from 0 to 2, right? But now, before we do 0 to 2, we forgot something. Is 0 included or not?
Included, ma'am.
0 is included.
Yes, 0 is included.
Do you see that? From
Yes.
0 is included, right? No, so meaning that it's from 0 to 2. So then we include 0. So the domain of f plus g is equals to, we include 0 to 2. Is that the only place where we see green?
No, ma'am.
No.
Oh.
2 and
It's
positive
also
infinity.
from 2 to infinity.
From 2 to infinity, ma'am.
Open bracket, close.
Open, ma'am.
Open.
Bracket.
Union open bracket.
Do we put union or end?
Ma'am. Union.
Union.
Thank you. You are saying me and you are meeting at UNISA Florida, or me and you are meeting at UNISA Sunnyside. Do you see that?
Yes.
That's
Yes,
why
ma'am.
you're saying or. So then that's how you find the intersection of the two. Then that's how you find the domain of f plus g. Does it make sense now? I'm not going
Yes,
to leave
ma'am.
you
It does
because
make sense
it's in the
on the
exam.
number. On the
Yes.
number line.
Do that. Then do the number line, because one day you'll have to explain it to someone.
Ma'am,
Yes.
please give me a clarity between the union and the intersection there. I'm still a bit confused now between the two.
Okay. So if I am saying me and you are washing dishes, meaning that me and you, we have to be both washing dishes at the same time. Do you see that?
Yes.
Me and you get paid the same amount. It means if I get paid 2 rand, you also get paid 2 rand. Do you see that? But if I say me or you will be washing dishes, it means I will be washing dishes, you will be washing dishes, or according to probability, both of us are washing dishes. Does it make sense?
Yes, ma'am.
So now, when it comes to this particular drawing, you are saying, where do I get the green? I get the green at 0 or 2. I get the green between 0 or 2. Or you can also get a green between 2 and infinity. That's why you're using 2. So intersection means that both of us have to be there. So if you're saying we are meeting at Junisa, Florida, both of us have to be at Junisa, Florida to meet. If we're meeting at Junisa Sunnyside, both of us have to be, that's the end, yes?
What if that 2 was a close circle?
Second, then it means that you are going to write the yellow on top as well. Do you see that? So you were going to put the yellow on top. So it was going to be from this side up to that side. And then you see that 2, then the 2 changes into green. Do you see that?
Yes, so which means I'm right if I say 0 and then up to the infinity.
Well done. So now it's from 0 up to infinity.
Um, sorry, ma'am. If it was,
Yes?
if it was positive, not yeah. How am I supposed to ask this? But if it was 2, x plus 2, not x minus 2, how is it going to be our coordinates, our domain?
Remember, if it's x plus 2, you say anything under the square root should not be 0. So what is anything? It's x plus 2 should not be equals to 0. Therefore, you transpose, then x is equals to, you're solving for x, basically. That's how it's going to be.
Okay.
Thank you. Now, according to what you have learned, what is the domain of f plus minus g? Guys?
The same.
The same. What is the domain of f times g?
Same.
They will be the same.
So what is the domain of f divided by g?
The domain
Okay,
of
sorry.
Oh, sorry.
Oh, sorry, guys. So this one is the set notation. Give me the interval notation. What do you think the interval notation will be? I mean, this is the interval notation. What do you think the set notation will be?
It's going to be x is an element of real numbers such that x is greater or equals to 0 and x cannot be equals to 2.
Thank you. Thank you. So it's easier because you just say this and this one. You just say this and that one. Okay, so you are saying that the domain of f plus g is the same as the domain of f minus g is the same as the domain of f times g. That's what you're saying?
Yes, ma'am.
Okay. Is it the same as the domain of f over g?
Yeah, yes, ma'am, it is the same. Oh, ma'am, no, it's not the same. I think it's going to be the domain of f of x over g of x. It's going to be x is an element of real number such that x is greater than 0 and x cannot be equals to 2.
Why? We all want to know.
Okay, okay, ma'am, because the reason is because, ma'am, x must be greater than 0, because if we put 0 on the denominator, we're going to get an undefined, meaning there won't be a function. So x must be greater than 0, meaning the values we must look into must be from 0,1 up until to infinity, in order for us to get a function.
Guys, did you hear that or no?
No.
Okay. So we found, okay, now let's just conclude this because we have been on this. So we found that f plus g is equals to 1 over x plus 2 plus the square root of x. Is it minus? Right? And we say the domain is this one. Now, f minus g will be 1 over x minus 2 minus square root of x, and we say the domain is still this one. Are we all together?
Yes, sir.
And then we say now we found f times g, which is equals in this case 1 over x minus 2 times square root of x, which is the square root of x over x minus 2. The domain is still this one. Are we all together there?
Yes, ma'am.
But so now listen to this. Now f divided by g is equals to 1 over x minus 2 divided by the square root of x, which is equals to 1 over x minus 2 times 1 over square root of x. So this is equals to 1 over the square root of x minus 2. Right? We say the domain of this one is equals to this one. But we remove values of x for which the denominator is the same. So let's do that. So meaning that the domain of f over g is what? Is x such that x is greater or equals to 0 and x is not equals to 2. No, what am I saying? Am I saying the right thing, guys?
No.
Why? Okay. So we are saying, okay, we're saying, let me repeat. We are saying that it's the same as this one, except for the values of x for which the denominator will be equals to 0. Are we all together there?
Yes, you're right, ma'am.
Okay, so now let's remove the value of x for which the denominator will be equals to 0. In this case, for which g of x will be equals to 0, what will be that value? Because in our notes, it says that it's f of x divided by g of x, right? Is the same domain as everything above, except for when g of x is equals to 0. In this case, our g of x is what? The square root of x, isn't it?
Yes.
Yes, ma'am.
So what is that value that will make the square root of x equals to 0? In this case, g of x equals to 0.
It's 0. If you put
It's 0.
0 in that square root, it's gonna be equals to 0, and anything times 0 is 0. So it's gonna make our denominator 0, which is undefined.
Thank you. So that's what they're saying, that if you're dividing f of x and g of x, the domain is the same as the above, but except for the values of x, that will make g of x equals to 0. So let's go and see. So we know our g of x is this one over here. So that's our g of x, which is this one over here. Now, since we know that if we put 0 in the square root of 0, then the domain will be undefined, meaning that we have to go and remove 0. So we go and remove 0. So then that's the domain of f of x divided by g of x. Does it make sense, guys?
Yes, ma'am.
I need 3 yeses.
Yes, ma'am.
See that?
Yes, ma'am.
Okay. So then we can continue now.
Yes, ma'am.
Yes, you can continue.
Okay, so there's something we didn't do here. What is it? It's this one over here. Right? So let's do that. Should we do it now, or you guys are okay?
Which one is that, ma'am?
Please do
We can do it, ma'am.
Okay, so let's do that fast. I'll just do it so that we save time, because I know that we have done this somewhere. So the number 2 wants us to find let me check with our slides. They want us to find f of x plus g for f of, so we are evaluating all the things that we have calculated at 4. That's what they are saying. So let's do that. So we know that our f of x plus g of x, they said blue, so I need to make sure wishes must be granted. So this is 1 over x minus 2 plus square root of x. So they want us to evaluate f plus g at 4. So this is the same as f of 4 plus g of 4, which is equals to 1, 4 minus 2 plus the square root of 4, which is here. We know that this is 1 over 2 plus 2. And what do we know the answer here? It's 5 over 2. Remember, we're not using calculators for this module. Now let's evaluate f or minus g at 4. So this is equals to f at 4 minus g at 4. So we know f minus g is the same as f minus g is the same as 1 minus x minus 2 minus the square root of x. So if we substitute, this will be equals to 1 over 4 minus 2.
Ma'am, please slow down.
Oh, sorry. Minus the square root of 4, right? So then this is equals to, we know this is 1 over 2 minus 2. So if we use the butterfly method, we know that this is 1 over 2, and we know this is 2 over 1. So we can just multiply the denominator from this side, which is 1. So 1 over 2 times 1 over 1 minus 2 over 1 times 2 over 2. So then the denominators, guys, with time, it will be easy for you to just be able to, what am I doing now? To see the answer. So this is equals to 1 over 2 minus 4 over 2. So this is equals to 1 minus 4 over 2. This is equals to minus 3 over 2. Are we all together there? Yes, no?
Yes, ma'am.
Thank you. The page is moving. I don't know why. Okay, let's make space here. So now we want to find f times g evaluated at 4. We know that f times g of x is just the multiple of f times g of x, which is just equals to 1 over x minus 2 multiplied by the square root of x. So this is the square root of x over x minus 2. So evaluating at 4, this means that we'll say f at 4 times g at 4. So this is equals to the square root of 4 over 4 minus 2. So this is equals to what? This is equals to 2 over 2, which is equals to 1. Now they want us to find f over g at 4. We know our f is what? Is 1 over x minus 2. Our g is square root of x. So we then go substitute. So f of 4 is 4 minus 2 over square root of 4. So then the answer will be equals to 1 over 4. Are we all okay there? So
Yes,
that's how we're evaluating it. Okay. So now let's move on and see if what we did was right or what. So they say the domain of f is x not equals to x element of real number, x not equals to 2, and the domain of g is x greater. X is an element of real number such that x is greater than 0. The intersection of the domains. Are we correct?
Yes, ma'am.
Well done to us. And then that's okay. Now they are adding the functions. That's it. And that's the domain. And because we know that the domain of f of x plus g of x is the same as f of x minus g of x, f of x times g of x. So meaning that you just go and subtract the functions, you get the answer and use the same domain as on top. Same here, you multiply them and use the domain that is on top. There we go. But as we said, here the domain is exactly the same as this one, except for the one that will make g of x equals to 0, meaning that we just remove 0 here, because then the square root of x for the square root of x to be 0, it means we need 0. So meaning that it will be exactly the same domain except for 0. And that's what we did. So they say, note that in the domain of f over g, we exclude 0 because the square root of 0 is equals to 0. Are we all okay up to that point? Yes or no, guys?
Yes, ma'am.
Okay. We're still on page 8. Each of these values exists because x equals to 4 is in the domain of each values. So they're saying that we can take x equals to 4 and substitute because it is found in the domain of all these domains that are mentioned here. So then we found the answers, we found the answers, we found the answers, and yes, we found the answers. So let's move to the next one. Now, they say the graph of the function f plus g can be obtained from the graph of f and g by graphically adding. This means that we add the corresponding y values as illustrated in the next example. Does this statement make sense, guys?
Yes, ma'am.
Okay.
No, ma'am. Can you elaborate?
Okay, so they say the graph of f and g are shown in the figure 1 using addition to find f plus g. So you can see this is g, right? This is f. This point here and this point, they share the same x value. Do we agree there?
Yes, ma'am.
Now to find, remember that we know that y is the same as f of x and y is the same as g of x. So g of x and y f of x are actually the y values. So what they're saying is that for you to draw f of x plus g of x, what do? You go and take the y value for here and add it here. Take the y value for here, add it here. Take the y value for here, add it here. So meaning if this was what? Let's say this is 0 and 3. Right? And this is what? This is 0 and 0. Then the new graph, if you add the y values, the new graph will be what? 0 and 3. It will start here, for example. If this one, let's say this one was, let's say this is 1. So this is 1 and 4. And then this point is, I don't know, 1 and, it can't be 4. 1 and 2, and this point was 1 and 4, then it means you add the y value. So meaning that the new graph will be what? Will be 1 and 6. So then the new graph can move like that. So you just add the y values, but use the same x value. Add the y values, use the same x value. Add the y values and use the same x value. Then you get the new graph and then you draw it. That's what they're saying.
Yes, I
Did I?
now understand.
Thank you. And that's what they did. Do you see that? So they say we obtain the graphs of f plus g by graphically adding the values of f of x to g of x, meaning just adding the values of x and the values of y and using the same values of x as initially. So this implemented by copying the line segment PQ on top of PR, so that's not important. Now let's come to combinations of functions. This is also in your thingy, in your assignment, and definitely in your exam. There's another combination of composition of function, which is also a form of combination of combining a function. So what do you think composition of function is? Guys, what do you think composition of function is?
Ma'am, I think composition of a function means when you add two functions, you must get a new function.
But then that's adding functions. That's combining functions. That's a form of combine. What is composition?
Ma'am, isn't it adding a function within a function?
Or
Not
combining,
adding,
ma'am. Or
but
maybe
putting.
ma'am, we are using the wrong word, meaning combining, not adding. Combining two functions to get a new function.
Ma'am, can I
Yes,
try?
but what are you combining? This is a different type of combining. Yes, please try.
I think it's when the output of one becomes the input of the other. Like when we were in high school, when they were saying maybe translate the graph along the y-axis, then it's changing x, like something like that, man. If
What
they
you're
say,
talking about is right, but it's not composition of function.
Can I try?
Guys, yes.
I
Can
think
try.
a composition of functions, it's when the two functions create another function. It generates another function.
When two functions do what?
When f of x and g of x generate another function.
That's combination of function.
Ma'am, can I try?
It's when
One try.
it's
One last try.
Okay, ma'am.
okay. It's when I think it's when the result of one function, then we take the result of g of x and substitute to f of x.
Yes. So when you take one function and put it inside another function, that's a composition of function. Now, when you're going to continue with there's integration and differentiation, you need to remember this composition of function then, because when you're in second years, you guys forget. Now when we ask you to solve, then you forgot composition of function. So meaning that if you take one function and put it in another function, that's called composition of function. So let's now let's consider a very important way of combining two functions. So composition is one of the ways of combining functions to get a new function. Suppose we have f of x and g of x. We may define a new function by calling it h of x, meaning that we took f of x and put it inside g of x. We took g of x and put it inside f of x to get the new function. The function f is made up of the function f and g in an interesting way. Given an example x, we first apply the function g to it, then apply f to the result. Hey, what did I say here? Does it make sense what I said, guys? To me, it didn't make sense, but does it make sense to you?
Yes, ma'am.
Yes, ma'am.
So what are they saying? Because you're saying yes.
Can you please repeat for us, ma'am, please?
It says the function h is made up of the function f and g in an interesting way. So you have x. This is what you have x, right? You take x. Oh, it's even written here. Let's continue. So in this case, f is a rule that takes the square root. G is the rule that takes the square, then add by 1, and h, okay, fine. Let's come here. In other words, we get the rule h by applying the rule g and then the rule f. Now, what they are saying is you take x first, you put in g, then you get g of x. Are we all together? Which is this one here. Then you take g of x and put in f of x, meaning that you take where you see x in f of x, you now remove x, you put g of x to obtain f of g of x, which is this new answer here. Does it make sense now?
Yes, ma'am.
Thank you. In general, given any two functions f and g, we start with the number x in the domain of g and find its image, right? Which is g of x. If this number g of x is in the domain of f, we can then calculate the domain of g f of x. Can someone tell us what do they mean by that? Guys?
Ma'am, can you repeat the question?
It's this one, the statement here. Let's read the statement and then tell me what do they mean. Guys, give me 2 minutes. I just need to drink water. What you need to do is read these two statements and tell me what do you think they mean. I just need to drink water, then come back.
Is ma'am gone? Can we talk?
Yes, you can talk.
Like, I don't know. Like, if they said, like, for example, if I'm given the graph of f of x is equals to x squared, and maybe g of x is equals to x plus 2. If I'm compositioning the two graphs, do I take the graph of maybe x plus 2 and then place it into the x value of the f of x is equals to x squared? Is that what it means?
Yeah.
Oh,
Yeah, I think so.
oh,
I think where there is x in the function f of x, you put the g of x.
yeah, I think I get it.
Sure. Mathematics is hard.
I think
Guys, anyone who
I think it's
understands this statement here?
like the simultaneous equations when you have to solve for x or for y, you make y substitute formula instead where there is x, you put that
The whole
that you
graph.
got from
You guys,
Yeah.
hello? Why can't I hear now?
The problem
Hello?
about me is the fact that it's my first time
Hello.
about this.
Hello.
Can we do example like in real life? Does this mean like if me and Tabo get married and then we become a parent, we are one, but in essence we are two in that same name in that family? Yo, ka dubeya jwale.
Don't overthink it.
Don't overthink it. Can I know? I'm asking someone. Can someone help them? You know yourself. Shout. I don't know how many of you are here. Please. Yes, libelwane. Libelwane. Yes. Guys, you know what? I want you to look at the statement and read it. And if it's not making sense in English, because English is not all of us our mother tongue.
Yes, ma'am.
You understand? Then translate it to your own language. Let's look at the first statement, because if you can't do that, and today I might extend the class because I need to finish the second session as well. Then I give you a break next week. And those who can remain. Let's look at the first statement. That's what you need to that's how in general. How about feel the function pedi?
Ma'am,
Can someone continue? And then if you can be able to translate it into your own language and understand it, then it's fine. Then explain to us.
So how about if the functions A2?
A.
Nka A1, we kenya ka mohara e nngwe.
Emahanyang. Abare unka. We start with re thoma ka eng? Before Madeline Tate, let's fix the statement, because if you are able to do that, then we are able to study your work.
But ma'am,
yes,
if we don't understand the term in English, then how can we be able then to translate in our language? Because the thing is, we don't understand what the statement means.
That's what I'm saying. Translate the statement. Given any two functions, okay, let's try with one language. Given any two functions, re thoma ka eng? Ka Sezulu, ka Sepedi, or ka eng? Ka Sesotho?
Afrikaans. Afrikaans.
Not Afrikaans.
Zulu.
Yes, then whoever is doing
Tell me.
Afrikaans, translate it and then explain it to us. Because we want, the reason why we're saying this is because if you can translate a simple statement in maths into your language that you understand, then it might be easy for you to understand what they're saying. So let's choose one language and let's try one language. And then translate the first, what I'm trying to say, this part only. This part only. Don't just read it. Maths, you don't just read. It's continuous. You need to make sure you understand what they're saying for you to go and apply it. Can we have one person volunteering?
Ma'am, I can volunteer, but I can only speak Afrikaans.
And then we'll need another Afrikaans speaking person to verify. Because I don't know Afrikaans. I can only hear there and there. Okay, then speak Afrikaans and then try to tell us what they mean.
Okay, ma'am. So basically, ons het twee equations.
Yes.
Ons het g of x en f of x.
Yes.
So, ons het f of x en hy kolletjie daarso en g of x.
Wait. You say we have two equations, which is f of x and g of x, right?
Yes, ma'am.
Now they say, okay, listen to this. We start with we start with a number x in the domain of g of x. Translate that.
Ons begin met 'n nommer van x in g of x. Ma'am, as I continue.
Yes, and find its image.
En dan kry ons die prentjie.
Does it make sense, the statement that you have read from the beginning?
Yes, ma'am.
Do you see that? So let me use a different language. How to thoma ka di-functions tse pedi? Okay, so ba re file di-functions tse pedi. Re thoma ka x e leng mo domain ya g. Right? For us to find the image. Does it make sense? So far, guys, does it make sense?
Yes, maybe it does.
Yes.
Do you see that? Now what happens then? Let's continue. If this number g of x is in the domain of f, continue with Afrikaans.
Ma'am, please repeat.
Remember you said that you find the image, right?
Yes, ma'am.
Now, if this image is in the domain of f, continue there in Afrikaans.
So as die nommer wat ons gekry het in die domein van x is, en dan gaan ons insit om seker te maak dat ons nog 'n equation kry.
Does it make sense, the statement, if you read it if you translate it in your language?
Yes, ma'am.
Guys, anyone else? Because now it says, if you are given two functions, right? Ngongo, yes.
Yes, ma'am. Yeah, was ungezwa.
Yes, you want to try it in isiZulu.
Yeah. So bathi mawuthi sinikezwe ama function awu2 u-F no-G. So
Yes.
so bese siqala ngokuthi sithole inamba u-X okuyidomain le ka-G. So u-X useceleni mase ukuthi i-domain le ka-G. Mase siyakwazi ukuthi sithole i-image ka-G of X. So i-image ka-G of X njengoba u-G eseceleni kuzobe u-G multiply by inamba le ka-X okuyidomain ka-G.
Okay, not multiply. Uma sithatha u-X ekudomain ka-G, right? Then singakhona ukuthola i-image. I-image is Y, meaning that we can be able to put u-X ngaphakathi ka-G ukuthola u-value of Y, which is G of X.
But ma'am, akufani nokuthi si-multiply u-X na u-G because vele uzobe ku-G of X.
Remember ukuthi uma uthatha from the domain, uyi-substitute ku-G of X, uthola u-substitute ku-G, uthola u-G of X, akusu-multiply lokho.
Oh, sorry.
It's
And
the
then
value.
Yes,
yeah,
let
so,
him finish. And then
mase bathi inamba le ka-G of X lesuke leso sisitholile mawukuthi ikhona nakwi-domain le ka-F lenye i-function ewu-F mawukuthi
yes,
inamba le khona naku-F so sesikwazi ukuthi si-calculate i-value ka-F G of X.
Does it make sense?
Yes, ma'am, it does now.
Just
Yes,
like that. So it does make sense. If you can translate any statement, guys, that's how I did my maths. I'm a township girl, so I combine languages, I learned languages, and I've been around different languages, except for Afrikaans. So if it didn't make sense, I use my own language. They say, if you are given, like me are these two functions, you take X and check, this is the domain of G, right? If X is in the domain of G, right? Then it means that you can find the image called G of X. And if this image is in the domain of F in here, then you can go and calculate G of X. That's what they're saying. So this is a rule, it's a skill that you need to go and use. If it doesn't make sense in English, go put it in the language that you understand. Are we all okay there? So can I continue?
Ma'am,
So,
can we
ma'am,
go
what
through a
does
few
what
examples?
does it mean, ma'am? It says you take you analyze the domain of X or of G of X before you do anything there. Because they say the X number or the X value is in the domain of G of X. So which means the first step you analyze the domain of G of X.
Yes. So meaning that, remember, G of X cannot have a domain. Guys, X has a domain.
What doesn't have a domain, ma'am?
G of X, because G of X is an image, it's Y.
Okay.
So let's continue. Now they say the results, we'll get to the example, then it will make it more clear. The result is a new function called h of x that is obtained by substituting g into f of x. And it is called the composition or the composite of f and g. And it's denoted by f0, that small zero there, g. F composed g. Okay? Now they say that compositions of function, given two functions f and g, the composition of f and g, also called the composition of f and g, is defined like this. So this is how we write it. Let me say this charge. This is how we write it. Are we all together there?
Yes,
so far. Thank you. Now let's go to the next one. I just want you to see something now. There we go. Do you see that? Now, it goes back to the statement. They say the domain of f and g is the set of all x values in the domain of g such that g of x is in the domain of f. Do you hear that statement, guys? Hello?
Yes, ma'am.
It goes back to saying that if you are given two functions, you start with x. This is what you start with x, right? Now, if we start with x in the domain of g, right? Which is in the domain of a function. And then we find its image. We substitute in this function here. Remember, a function is a domain. We substitute in that function there. And then x is in the domain. So the domain of g, this is the domain where you find all x values for which g is defined. You then substitute in g to get g of x. Do you see that? After finding g of x, which is the image, it means that whatever now, those numbers that you are getting after substituting x into g of x, you are getting these numbers, all these numbers that are in here, right? Those numbers are the domain of f. Meaning that this is the domain of g, this is the domain of f. But you took x, you put in g to get g of x to get these values in here. These values in here will be the domains of what? Of f. Therefore, since then, these values that you obtain, g of x is in the domain of f, it means you can be able to calculate g of x. Are we all together there now? Yes. Yes?
Ma'am,
Yes.
If I say composition of a function, ma'am, is that we take an output of one function and use it to another function as an input to get a new function.
Yes, but you cannot use that output if that output is not the domain of the new function you want to put in.
It makes sense.
Does it make sense now?
Yes. Ma'am, please, can we do an example of what you're saying? Maybe give us two graphs and then we apply
the example. The example will be easy. I just wanted you to find the theory behind it first. Do you see that? So meaning that x has to be in the domain for this to be defined, right? X has to be in the domain of G, and it also has to be in the domain of f and g of x.
When you're looking at the structure, it makes sense, ma'am. But now I would like to see you making an example so that we can have a clear picture of what is happening to this structure.
Okay. So now they're saying, I want you to hear this for the last time. The domain of this is a set of all the x values that are in G. Ne? Such that G of x is in F. In other words, listen to this. This is the important statement. In other words, the composition is defined whenever both G of x and f of x are defined. This is the statement. They say the domain of this is only defined when g of x and f of x are defined. So what do you think is it? What do we look? Which domains are we looking for, and what are we doing to those domains to find the domain of a composition function, according to that statement?
We combine them.
How?
Compose.
We're going to look for the domain of f and the domain of g, and then combine.
We need to combine them.
We need to find the intersection.
Okay.
Are we all together?
Yes, ma'am.
Yes, ma'am.
G and that. So let's continue. Now they say that, oh no, this is not a good example. Because it's more easier
Let's start with the easier one, ma'am. Then we're gonna
Okay.
go to the difficult one.
Okay, so now we have f of x. So now they're saying that find the function, the composition of this and that. So they want you to find compose G. Now, when you're composing, you're taking one function and putting inside the other function. Which one is the inside function? Let's call it the inner function. Is it f or g in this case?
G.
There we go. So f, then put in g of x. Do you see that? So what is f? F is x squared. Do you see? Right?
Okay.
Now where you see x, remember we had f of x. Now we want f of g of x. Where you see x, you put g of x. So this will be g
X
of
squared.
x squared.
Okay.
And what is g of x? G of x is x minus 3 squared.
Minus 3.
Then you have done the composition of functions.
Ma'am, where is the squared coming from the gx squared?
It's coming from here. Do you see that?
Oh, okay.
Yes.
You just substituted the x minus 3 inside
Yes.
the. Okay, now it makes sense.
So let's go to g of x. Let's start there. Or maybe should we find the domain first? Okay. Now let's go back to the statement. So they say for the domain of this, which domains are we supposed to find?
The domain of
F
G.
times G.
Now in this case, it's the domain of the inner function, right? And the domain of the expression of the composition. The reason why I'm saying the domain of the expression of the composition, I don't want to say the domain of the composition. And don't get confused. The domain of the composition, we'll write it like this, right? Is the intersection of the domain of the inner function, which is and the expression. Let's put it like this. Are we all together?
Yes.
So, what is the inner function in this case?
G.
So g of x is the inner function. So meaning that we are finding the domain of the I. Let's call it I, which is the inner function. In this case, we know g is the inner function. What is the domain of the inner function?
X minus 3.
Cannot be
Domain,
3.
guys.
X cannot be 3.
Why cannot be 3?
Ma'am, the domain, ne?
You say
Yes.
G of X is equals to 0.
X is less than.
X is the element of real numbers
Why?
because it won't give us an undefined answer.
Thank you. Remember what I said to you guys. What value can you substitute in g of x that will, in a calculator, because you guys liked calculators, can give you an undefined answer? There's nothing. You can substitute 1 trillion in x, you'll still get an answer. You can substitute 0, you'll still get an answer. You can substitute 0,011 at x, you'll still get an answer. For as much as you can substitute any value of x here and get an answer, then the domain is any value of x in the real number. Therefore, x is an element of real number. Are we okay there now?
Yes, ma'am.
Yes, ma'am.
Thank you.
Yes, ma'am.
Now, what is the domain of the expression? Where is the expression? Give me the expression. Which one is the expression?
X squared. X minus squared.
Thank you. X minus 3 squared. So what is the domain of the expression? Let's call it the expression, domain EX. What is the domain of the expression?
It's going to be the same as G.
Thank you. Which is X element of real number. Do we agree?
Yes.
Yes.
Yes, ma'am.
So
Yes,
what is
yes,
the
yes.
intersection of the two?
They want to be X elements of real numbers.
Thank you. Because if you draw a number line, if they say from negative infinity to positive infinity, this is the first domain, and then you come and get again and draw the second one from negative infinity to positive infinity, it means the domain of this will be what? X element of real number. So meaning that the domain of this, the entire thing will be X of element of number. Therefore, the domain of F and G, the composition is X element of real number. Make sense, guys?
Yes, ma'am.
Yes, ma'am.
Thank you. Okay. Should I leave you to do this as a homework? Because I said it's more easier. I want to do a bit complicated one.
Yes, ma'am. Please.
So let's see which section is this? 2.7. I want us to do the one in the thingy, in the textbook, so that you see.
Ma'am, was that one not in a textbook?
Yeah?
The previous slide was not in textbook, ma'am.
It is, but it's a simple one. That's the thing. It's in my textbook is on page 117. It's example 3. But I want this one. You see, the one that will show us flames so that we understand the flames.
Yes, ma'am.
Yes. So example 4 on page 218. For others, if they're using the 7th edition, I don't know which page because I don't have my 7th edition with me. It's on campus. But now it says that if we have f of x is equals to the square root of x, right? And we have g of x is equals to the square root of 2 minus x. Are you all together there?
Yes, ma'am.
Now they say we have A. A is the composition. This is what they want us to find. We know that this is the same as g of x. Can someone give me the answer? I go and see, where do I put what? Guys, this is in your assignment and in your exam.
Ma'am, can I try?
Put G and F.
The person who said they can try, they try? Yes, please try.
Okay, ma'am, you're gonna say
It was a lady.
Maybe it can be square root of square root a 2 minus x. I'm not
So
sure.
square root, wait, you can't say square root of 2 minus x. Let's do step by step now because we're doing it in class.
Okay, ma'am.
Yes. So it will be the square root of what? According to this. The square root of g of x.
X, ma'am.
So meaning that we know we take wherever we see f, this is how we see f. We remove x, we put g of x here in here, and we remove x, we put g of x in here. That's what they are saying. So let's do that. So this will be square root of g of x. Do you see that?
Yes.
But do we know g of x? Yes, we know g of x. So we put g of x. What is the g of x? Square root of g of x? Thank you. It's the square root of 2 minus x. But we can't leave it like that. I said the square root of a is the same as a to the power of what? Last time.
A
to the power of 1 over 2.
Thank you, 1 over 2. So meaning that the outside square root is what? Square root of x, 2 minus x to the power of 1 over 2, isn't it? Now the inside one, it will be 2 minus x to the power of 1 over 2 to the power of 1 over 2. And we know 1 over 2 times 1 over 2 is 1 over 4. So this is 2 minus x to the power of 1 over 4. And if you put this in a root form, it will be the fourth root of 2 minus x. Are we all together there?
Yes, ma'am.
Yes.
So
Yes,
now
ma'am.
I want to find the domain of the composition of this function. Where do I start?
You start with the of the
Inside
inner
the
function.
bracket.
Thank you. It's the composition of the inner function. And then end. Or end. Union or intersection?
Intersection.
Intersection. What?
Domain of the.
Thank you. The domain of the expression. The domain of the EXP. Let's call it EXP, the expression. Are we together? Now let's go find the domain of the in, which is our inner function. What is our inner function in this case?
The square root of 2 minus x. G of x.
Thank you. So meaning that our inner function is the domain of g of x. What is the domain of g of x?
X
X is
cannot equal to 2.
0.
That's that.
So x is such that 2 minus x should be what?
Not 0. Greater to or equals to 0.
Why?
Gonna give
Because
us undefined.
everything, thank you, because everything under the square root should be positive or equals to 0. That's why we say greater or equals to 0. In maths, when we say greater or equals to 0, we mean that it is equals to 0 and all the positive values. So since we know that if we take the square root of a negative number, it's undefined, therefore meaning everything under the square root should be greater or equals to 0. So let's simplify. So then this will be equals to x such that we take 2 to the other side, so greater or equals to -2. Then this is equals to x such that x should be less or equals to 2. Are you all okay there?
Yes, ma'am.
Now, set notation, less or equals to 2 will be from negative infinity to 2 included. Right? Now,
Yes.
we are done with the domain of the inner function. So we go and find the domain of the expression, which is this one here. Right? So what is the domain of the expression? Look at the expression. Here's the expression of the composition function. This one, the one we found here. What is the domain? So let's say the domain of the expression.
I think the domain of the expression is going to be x is the element of real numbers for which x must be greater or equal to 0.
Not x, but what is under the square root? The fourth root.
Under the fourth root.
It's
2
minus x. Thank you. 2 minus x should be greater or equals to 0. Do you see that this is actually the same? If we simplify, this is just the same as the other one.
Yes, ma'am.
So then this is equals to from negative infinity to 2. Now, by looking at this, the intersection, is it obvious?
Yes,
guys?
Yes.
Yes.
So, thank you. So therefore, the domain of F intersect G is equals to x such that x is less or equals to 2, or you can write it as negative infinity to 2 because it's the same thing. So it means they are intersecting. That's the domain. Are we all together there?
Yes, ma'am.
Thank you. Let's move to B. Now this is a bit of a long section. Let's move to B. The B says f of x is equals to the square root of x and g of x is equals to the square root of 2 minus x. Now they want you to find g0f in x, meaning they want you to find g in f of x. Give me the answer.
The answer will be the square root of 2 minus the square root of x.
Before that, let's do step by step. Remember, we are in class. We are not in the assignment or in the exam. So we don't want the final answer yet. We want step by step.
G in a function of f of x.
So you take, what do you take? Where do you put, so So it will be the square root of what?
Of 2 minus x.
Of 2 minus x.
Ma'am,
Look, yes?
No, the square root of x, because it's f of x, ma'am.
Yes?
Will
Going
it
to be
square root
instead
of 2 minus f of x?
Thank you. It's going to be the square root of 2 minus f of x. Are we all together? Oh, I'm losing someone there.
Okay, yes, we are together.
Because look at this. In G, go put f of x. You put f of x. Here you put f of x. That's what they're saying. Do I know my f of x? Yes, which is this one. So then I go and substitute 2 minus f of x like this. Is it easier now?
Yes, ma'am.
Yes, ma'am.
Now the domain of G of f is what? Is the intersection of what? The domain of the inner function and the expression. But then what is the inner function in this case?
Of x.
F of x.
This is, yes, the inner function is a function that is inside. So that's the domain of f and the domain of the expression. And we know the expression is the composition, this one we found here. I don't want to say the domain of the composition, but the domain of this expression here. So therefore, we go and find the domain of the inner function. What is the domain of the inner function? In this case, our inner function is f. So what is the domain of f?
X is greater or equals to 0.
Thank you. So it's x element of real number such that x is greater or equals to 0, because we know that everything under the square root should be equals to 0. Now with the interval notation, how do I write that? From
0 to infinity.
Thank you. From 0 to positive infinity. Well done. Now we are on the same page. So what is the domain of the expression in this case?
Two minus the square root of x greater or equals to 0.
Well done. So therefore, x should be element such that 2 minus the square root of x should be greater or equals to 0. Remember what he said? Everything under the square root should be greater or equals to 0. That's the domain. So meaning that we can go and simplify. So this is x such that, help me simplify, guys. Algebra. What do? I take 2 to the other side or the square root. Help me.
You take 2 to the other, to the right.
Okay.
And
so then greater or equals to 2. So it becomes what? 2 or negative 2?
Negative 2.
Negative 2.
Thank you. Then equals to?
Then we cannot leave the square root as a negative, meaning you're going to divide by -1 on the left, and the same as to the right.
Thank you. Then what happens?
The sign changes, ma'am.
Thank you. The sign changes. This is an inequality. Then what?
Square.
Yeah, and then you square both sides.
Thank you. Guys, you see, it's not like you are doing something you don't know.
Then your final answer is going to be x, the element of element such that x is less than or equals to 4.
Thank you. So what is the notation, interval notation for that?
The interval notation.
Wrong bracket. What is the interval notation for that?
Positive infinity 4 to positive infinity.
Positive infinity.
No.
Negative infinity to 4.
Negative.
Negative infinity to 4, ma'am.
Thank you. Now that we have the inner function and we have the, what is the intersection? Isn't that they're saying that the domain of the composition is the intersection of the two? We are here. We found our two domains. Let's find the intersection. Should we draw a number line?
It's going to be.
Okay, let's draw the number line, guys. Here's the number line. Which domain are we starting with to draw? Remember, we're drawing the two domains. So we'll draw them on the same. One will be yellow, one will be the other one. So which one are you starting with? Any. Let's start with the inner one.
With
From
the-
0. So it says from 0. Do I go to the right or to the left? And do I include 0?
Yes.
To the right, include 0.
Right.
So then, remember inclusion means a solid circle. So 0 to the right. So 0 from here to the right. Okay, I'm done with this one. The second one, what does it mean?
To start from negative infinity.
We included.
Okay, where do I put 4? After 0, before 0?
After 0.
4 included.
Yes, ma'am.
Solid line. So meaning let's use a different color, in this case blue. So it says from 4 to
Negative
infinity.
Okay.
So then what's the domain of the intersection?
Negative infinity to 4.
0 to
No, 0 to 4.
Well done. Included or not included?
included, both of them.
Both included.
Should I trust you to do the remainings for yourself?
No, Mom, don't trust me. Let's do
Guys,
it
you're
together.
extending the class. Otherwise, you'll leave at 4.
Let's do it together, Mom.
As long as we understand when we leave at 4, man.
Okay. So you understand this one? I didn't help you, and the answer is the same as the one in the textbook. Okay, let's go to the next one. So the next one, I was asked for blue. The next one says, now do you see that the composition of F and G of F are not the same? Did you see that, right?
Yes, ma'am.
Thank you. So let's go to C. C says F, what am I saying? F, then X. So it means that it's F in F of X. And we know that F of X is what? Is the square root of X. And we know G of X is equals to the square root of 2 minus X. So meaning that F of X will be equals to what? The square root of F of X, which is the square root of the square root of X, which is the 4th root of X. Do we agree, isn't it?
Yes, ma'am.
Yes, ma'am.
So now the domain of F compose F is equals to the intersection of the inner and this intersection of the expression, which is the expression. Now our inner function is F, so it means the intersection of F and the expression. I know in the textbook they didn't write the expression. Okay, so meaning that we need to go, what is the domain of the inner function? We know that the domain of the inner function is X element of a number such that X is greater or equals to 0, meaning that it's from 0 to infinity.
To infinity.
Yes. So now, what is the domain of the expression? The domain of the expression? What is the domain of the expression, guys? The expression of the composition in this point. It's what? Guys, you were right in the right track. Now you keep quiet. What is the domain of this?
Can I try, ma'am?
Yes.
Say it's 0 to 4.
Oh, please try.
It's greater than 0.
Yes, because everything under a root, whether it's a square, a cube, a fifth, a whatever, should be what? Should be positive, greater or equals to 0.
Ma'am, including the cube root.
Yes. Go and put in the calculator. They should be greater than 0, should be positive.
Yes.
The 4th root, this is a 4th root. The 5th root, the 8th root, the the root, the $17 million root, the cash, yeah, root. It should be positive. So by looking at this, we don't have to draw number line, ne?
Yeah, it's obvious.
Danko. One last one. So then we have g of g, and we know g of x is equals to the square root of 2 minus x, and g of g at x is the same as g of x, which is equals to this one. You will do it, not me, because I don't understand it. I'm assuming my brain is telling me I don't understand it. So meaning that it will be the square root of 2 minus g of x, which is equals to the square root of 2 minus
Square root of 2 minus x.
Danko. That's the expression. Now they're saying that the domain of g is equals to the domain of the inner function in and intersection the domain of the of the composition function. And this is the of the composition function. So let's go. Find the domain. What is in the inner function? In this case, the inner function is g because it's inside g, and the exprr. Now, what is the domain of g? Let's start with the domain of g. We say x such that
x must be less than or equals to 2.
Yes. Let's do it step by step because this is class. We know that everything under the square root should be positive. So meaning that this is equals to 2 minus x should be greater or equals to 0. So therefore it means that this, I am doing this step by step because this is a class. Therefore we do it like a DC, and then this, and then becomes this divided by -1 or multiply by -1, then they change sign. Are we all together in this boat?
Yes, ma'am.
Now, give me the domain of the express.
Is the 2 minus the square root of 2 minus x is greater or equals to 0.
Well done. 2 minus 2, what am I saying? My brain is giving me leave days. Minus x, greater or equals to 0. Then we do what? Leave it like that.
No, we transpose.
Before we transpose, can we fix this one? So that if the answers are not the same, interval notation, please.
It will be negative infinity to negative infinity to 2.
Negative infinity to 2 included by a donkey. Thank you. So let's go back to the express. So the express, we said it's x element of roll number such that the 2 minus the square root of 2 minus x should be greater or equals to 0. So then, help me. What do I do?
You transpose 2 to the right hand side.
Thank you. So then you're left with minus square root of 2 minus x is greater or equals to minus 2. Then what?
You square both sides now.
You square both sides. Abe.
No.
Divide by -1.
Thank you.
Change
You cannot
the equality
square.
sign.
Yes, because the negative, that negative next to this negative is making us do the mabena. You can't use that. So you need to remove that. So therefore, this will be divide by or multiply by the negative. Then it changes sign like this. Then after that, you can then square both sides. So then this is square root of 2 minus x squared less squared. What you do on your left, you do on your right. What you learned in grade 3 is still important even today. So 2 minus x less or equals to 4.
And
then what?
You transpose the 2 to the right hand side.
Danko. Then say x, then x less or equals to 4 minus 2. So then this is equals to x such that minus x is less or equals to, what is this? What is this? That's 2. Then what?
You divide by -1.
Again.
Thank you.
Equality changes.
Thank you now. Then what?
Then you have your answer.
Then what?
Okay.
I want both notations.
And then you can say from negative infinity to negative 2.
Negative 2.
Negative 2 to
Negative
infinity.
infinity. 2 to positive infinity.
Please go fix that. Negative 2 to positive infinity. So we have the domain of the inner function and the domain of the expr. Then what do we do now? Are they the same?
No.
No.
If they are not the same, what do we do?
Number line.
Danko. Do that. So the number line. Okay, let's choose a different color. The number line. So let's start with the domain of the expr. Here's the domain of the. Okay, let's start with this domain. Help me. Where do I start? Where do I draw?
From negative infinity to 2.
So I put 2 here, negative infinity to 2, and 2 is included, so it's solid. So from negative infinity to 2, let's choose blue. From negative infinity to 2. Are we all right? We're done with that one. The next one?
Yes, ma'am.
Negative 2 into infinity.
So minus 2, do I put it here?
Underline.
No, ma'am.
Danko, is it included?
Yes.
Yes,
So
ma'am.
meaning it touches the blue as well. So then where do I go? Right or left from negative 2?
To the right.
The right. So what is the domain of the composition now?
Negative 2 and 2 left.
2 and 2.
Thank you. So it's what? It's x such that it's from negative 2 included to 2, or it's just like this. Done. Are we happy now? Huh?
Yes, ma'am.
Yes.
Thank you. So if you go and practice it, we'll be so happy, extremely happy.
This, yeah.
Yes, so this one you'll go and do it by your own because it's easier. And I'm just going to skip and skip and skip and skip and skip and skip and skip. This was a very long question. Now they say you can see from example 3 that in general, please mute f of you can see. So they're telling you that the f composition G is not the same as G composition F. Remember that the notation f0g means that the function g is applied first and then f is applied second. It is possible to take the composition of 3 or more functions. For instance, the composition of fgh is found by first applying h, then applying g, then applying f as follows. Give me an answer. I'm plugging you guys here. You need to be plugged so that you get good marks in the exam. We all pass. We are paying.
I don't understand what's happening here, ma'am.
They want you to find this. What do we start with? Which is the inner function? In this case, there are 2 in functions, but which one is the inner?
H.
H. So we start with, they say H, then what? Which one is the outside function?
F.
After H. It's what?
G of x.
G. Then we have
F.
F. Do you see that?
In simple terms, ma'am, this means G is the inner function of F, and then H is the inner function of G.
Yes.
Okay.
So meaning that what we need to go now, do we know H of, do we know G of X?
Yes.
Yes.
So we know G of X, isn't it? Which is X to the power of 10. So what do we do with G of X?
You put it inside f of x.
No, you start here. What do? We put
inside f of x.
Exponent. 10.
That here. What is inside G of X here?
What is inside G of X?
H of X.
There's h of x, which is x plus 3. And then we're gonna say add exponent 10 because.
Do you see that?
Yes.
Now this is that inside. So meaning that we need to take it now and put it where? Inside of F. So then this is G of H of X is equals to G of H of X over G of H of X plus 1. And we know G of X is what? X plus 3 to the power of 10 over X plus 3 to the power of 10 plus 1.
Why are we dividing?
Why are we dividing? It's because of this. It's X over X plus 1.
X over X plus 1.
Yeah, bro. Are we okay now?
Sure.
Yes,
Okay.
This is your assignment too, guys.
That's why we're struggling to write it.
There's the question. There's the answer. And it's exactly what we did. So let's move on. So far, we have used composition to build complicated functions from simpler ones. But in calculus, it is useful to be able to decompose a complicated function into a simpler one, as shown in the following example. Oh, aha. What do they say now? This is the last question in your assignment. What do they say? What do you think they are saying?
I think they want us to reverse.
Danko. Let's reverse. So what do you think F will be and what do you think G will be? And when you choose your F, make sure that when you do F and G, it gives you the bigger F.
Can I try, ma'am?
Yes, thank you. So F of X will be what? G of X will be what?
Okay, f of x will be 4 over the square root of x, I think. And then yes, 4 over the square root of x.
Why are you saying 4 the square root of x?
Actually, I know my g of x will be x plus 9. When I'm looking for the f of g, it will be the...
Okay, let's say, okay, you're saying it's 4 over the square root of x.
No, I'm wrong. No.
Thank you.
Can I try?
Hey, let her continue. She knows she's wrong. She needs to fix it. Okay, so then it will be?
Let me
Huh? You said G will be what?
G will be x plus 9.
And then this one, F will be what?
X.
Because she saw she's wrong. So you know what F is.
Yes, it's
gonna be what?
4 root x.
4 root x. The fourth root of x.
Can I help?
Yes.
Are you saying this? The fourth root of x?
Yes, ma'am. I'm saying that.
So let's substitute. So then F G of x is equals to the fourth root of 4 G of x. Let's substitute to see it's right. Well done.
Thank you.
What else? Guys, can someone give another example? Some questions, they even have more. Like one in the exam, in the assignment.
Yes,
Yes.
I was in the square root.
So for f of x, we can say it is the square root of x. And then for g of x, you can say it's the square root of x plus 9.
Okay. This one I didn't think about it. Let's see. This one sounds nice, eh? Let's see. So f of g of x then we know it's the square root of g of x, which is then the square root of the square root. Wow, well done. Well done. Do you see that, guys?
Yes.
Another one.
Oh, another one is going to be f of x is equals to x to the exponent 1 over 4.
Mm-hmm.
And g of x is going to be x plus 9.
That one.
Yes.
So do you see that you guys now can go and do your assignment?
We are done with the assignment.
And then that's good. Then you can go and do your exam now. Study for exam. While now you are doing the exam. Application of composition function. How this section is not finishing. Application of composition of function, guys. There we go. They say when working with a function that models real-world situations, we name the variable using letter that suggests a quantity being modeled. We may use t for time. Some people, okay, let me not talk too much. D for distance, V for volume, and so on. For example, if a air is being pumped into a balloon, then the radius R of a balloon is a function of the volume V of air pumped into the balloon. Say R is equals to F of V. Also, the volume V is a function of the time and that the pump has been working. Say V equals to G of T. It follows that the radius R is a function of time as well. So that's a composition function. Guys, do not take these questions for granted. And you notice that almost every section, there's a word problem. I know word problem in chapter 1. I need to come back to you guys and explain. Those ones, don't worry. I'll go. Maybe we might have their own sections. But have you noticed there are applications? I am going to ask you questions like this in the exam. So let me go drink water. And then you discuss. After this one, I think we done. Let me see. Yes, it's the last question in the textbook. After this one, then we are done. Please analyze it first, then draw, then we talk.
Sure. I just need an physics.
What's happening?
Wow, this is confusing. Shit.
Yo, gosh. Thank God. I think we should use physics strategies for hassles.
Is 20 mi per hour meters per hour?
I don't know about
Is
the
it
R.
miles per
I don't
Or
hour?
is
know
it
about the
minutes
R.
per hour?
Miles per hour.
I think
Ah,
they made a
miles. That's
mistake,
traveling.
but it's supposed to be m divided by h. I think probably they made a mistake.
That's the S. And for
But for distance, it always has to be an m. Yo, so the suffer, guys.
It just confused school.
I think our distance is 5 miles or whatever that is, but it's not miles.
Is it miles?
what does stand for actually?
Is it miles per hour?
It's miles. It's
Yes.
miles.
Yeah, it is.
Yeah, it can be miles per hour.
We're solving for what?
Express the distance.
Are we
as
supposed to convert it, or it should be like that?
The distance is 20 miles per hour, I think.
No, the 20 miles
think
per
it's not the
hour
same.
is the speed that is traveling in, but
Thank
the
you.
ship is 5 miles from the shore. So we have the distance, which your delta x is 5 miles, and then the speed at which the ship is traveling is 20 miles per hour.
We're just gonna use the miles. We're not gonna convert. We're not gonna do anything.
I don't know. That's what I don't know.
But I
Guys,
don't think
this is not math literacy, and I'm not going to ask you to convert anything here. Right? Remember
Yeah.
what I said initially from our classes. Please mute, someone is disturbing me. I said initially from our classes, you know, our textbook is not South African and it doesn't use the metric system or African, or let's say it doesn't use the metric system. So theirs are more of miles per hour instead of kilometers or meters, right? So in the exam, the question, if the question comes, it will say a ship is traveling 20 kilometers per hour parallel to a straight shoreline. The ship is 5 kilometers away from the shore. It passes the lighthouse at noon. Does it make sense?
Yes.
So when it comes to the exam, we'll be using our own units, the metrics units we are used. Instead of pounds, we'll be using rands. Instead of dollars, we'll be using rands. Is that okay?
Yes.
Thank you. So let's say it's 20 kilometers per hour then. Let's remove the mile. Let's put km so that it doesn't confuse you. And then this is km. There we go. Let's solve the problem. Let that not be the problem. So what's the first thing you do?
We need to find
Let's
the
equate
formula.
everything.
Why are you finding, guys? What are you finding? Let's analyze the statement. A ship is traveling. Let's start there.
I think we find the it says express the distance.
Don't find the distance. It's not going to make sense.
Okay.
Draw the question if you have to draw. Don't find the distance. Let's look at this. Forget about A, B, C. Forget about them. Forget about them. Let's look at the statement, because if you don't understand the statement, then you won't be able to solve for A, B, C. What is there?
Ma'am, I think the ship is 5 kilometers away from the shoreline.
Okay, what is the shoreline? Let's start there. What is the shoreline?
I don't know. I'm assuming where it needs to go.
Guys, what is the shore?
It's the sandy part of the beach.
It's the sandy part of the beach.
Yes.
Yeah, it's the
Do you
beach.
see that? So here's the sandy part of the beach. This is us, MAT1510 2025. We are at the sandy part of the beach. Do you see that? This is us, all of us here. We are at Durban because Cape Town is very cold, the water, right? And then they are saying that the shoreline is this line here. Do you see that, guys? This line here, it's the shoreline, meaning that there's water after the shoreline.
Yes.
There's water after the shoreline, right? So this is the shoreline. Are we all together?
Yes,
Ma'am, the shoreline is where there's sand and then the beginning of the ocean.
Yes, of the ocean. So where there's the shoreline is where the ocean ends. In this case, if the water is coming up, then there's a new shoreline. If you have been to Durban, you notice that the waves are coming, and then there's water, and then the water ends here. Maybe it ends here. After that, when another wave comes after end here. So let's assume that the water comes and hits here every time. Let's assume there's a boundary, like there's a big rock, not a rock, but there's a big, what do you call those things in the highway that protects the road from you jumping to the other side? These things, the boundaries.
Barrier.
Trash barriers.
Yeah, yes, that barrier. So then this is us there. We're not even answering the question yet. This is us. And then the water is here. This is the water. Right? That's what they are saying. This is the water. So we are just separating the shore from the shoreline. This is our water. Water all over, water all over. So let's start with the statement. So what is it saying? It says a ship is traveling 20 kilometers parallel to the straight shoreline. So meaning that where is it traveling? Which line? When they say parallel?
Straight line.
Straight line, right? Which looks like a shoreline as well. Because it has to be parallel to the shoreline. So meaning the ship, is the ship traveling like this, guys?
No.
No.
You
No.
see that? So it's not traveling like that, but it's traveling like this, right? Or like that, because this line is parallel to the shoreline. Does it make sense?
Yes,
Yes.
Yes, ma'am.
The ship is 5 kilometers from the shore. What are they saying?
The distance between the ship and the shoreline is 5 kilometers.
Thank you. Meaning that if the ship is here, from here to there, that's 5 kilometers. The distance from here to there is 5 kilometers. Wherever the ship is, straight is 5 kilometers. Does it make sense now?
Yes.
So meaning that if, let's say these two lines, if my ship was here, then the distance from here to here, okay, why am I getting star now? I know we are stars. I know. So from here to here, it's 5 kilometers. If the ship is here, the distance from here to here is 5 kilometers. Are you all okay?
Yes.
Now they say it passes lighthouse at noon. So meaning we need to go and draw a lighthouse, isn't it? So here's our lighthouse. And we know that the lighthouse normally is where at the shore. Have you seen a lighthouse in the water?
In movies, yes.
Yes.
Here's a lighthouse, right? So let's say we are moving, our ship is moving like this, and it goes and passes. Let's say it passes, it's here. Let's assume the ship now is here. Do you see that? Here's our ship. They say it passes the lighthouse at the noon, right? Now, what do we know? We know that the distance from here, let me draw with the green. The distance from here to the ship is what?
5 kilometers.
5 kilometers.
5 kilometers. Do you see that? Are we all okay?
Yes.
Yes.
And because these are parallel, what do we know if we draw a transversal, a line that passes through them? It forms
90 degrees.
90 degrees. Thank you. It forms a 90 degrees when we draw a transversal. Are we all okay?
Yes.
Now the question is, express the distance as from the lighthouse and the ship as a function of d. Meaning, where's the lighthouse? It's here, isn't it?
Yes.
Where's our S? Okay, sorry. Ooh. I don't know why there are circles being drawn here. So here's the lighthouse to the ship. Are you all together?
Yes.
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 So this is the lighthouse to the ship, meaning that our 90 degrees in this case is here on the top. Are we all together? Now they are saying that, okay, fine. Make it D. This is D. That's what they are saying. They say, I'm lying. They say express the distance S between the lighthouse and the ship. So this is S. Are we all together?
Yes.
The function of D, the distance the ship has traveled since noon. Where do I put D? Guys, where do I put D?
At the shoreline.
Top, next
the
to
At the
shoreline.
top. Thank you.
Yes.
Because I know that from here to here, this is the distance that the ship has traveled from noon. Are we all together?
Yes.
That's the distance traveled from noon. So they want me to find S, where S is the distance between the lighthouse and the ship. So what will be what am I going to use there?
Pythagoras.
Pythagoras.
There we go. So then we know that Pythagoras says the hypotenuse is equals to the sum of the two squares of the sum of the two. Do you see that? So meaning that S is equals to the square root of what? D squared plus 25. Are we all together?
Yes.
Yes.
Yes, ma'am.
Now they say express D as a function of time. The time elapsed since noon. That is, find G so that D is equals to G of X. So they want you to express D as a function of time. What do you think we'll do?
Derive.
It's going to be
D as a function of time. This is A.
distance divided by speed.
Thank you. What do you know about the speed? Speed is equals to what?
Distance over time.
Distance
Over time.
Speed is equals to distance over time. So now they want you to express D as a function of time. And what do we know about, okay, so we know our distance. If D is our distance, ne? Let's put D here. And we know here our time is here. What is our speed?
It's 20.
20 kilometers
Thank
per
you.
hour.
20 kilometers per hour, which is equals to distance over time. Therefore, it means our D is equals to 20 times T.
Times T.
Yeah.
Do you see that we are answering according to the drawing?
But ma'am, what does the noon stand for in this question?
X.
In this case, the noon is just telling you the time that the ship has passed the light, the lighthouse. It's not saying anything.
But they didn't tell us what time the ship started traveling.
Yes, they're just saying that at 12 o'clock, the ship passed your lighthouse. That's what I said to you, draw. It's very important, especially in trigonometry, you will want these drawings. Okay. Now, we know our A. Okay, we didn't express them properly. Our S, they said S must be f of D, which is the square root of D squared plus 25. And then B must be D is equals to G of T. In this case, it's 20 times T. Now they say find the composition of F and G. So we know what the composition of F and G is, meaning that you say F, G of T. That's what they want, which is equals to, I know my F is this one, so then I'll do G of T squared plus 25. So then this is equals to 20T squared plus 25. Then the answer is, okay, let's leave it there. Ne? Now they say, what does this function represent?
Composition of functions.
This one, what does it represent? That composition of function.
expression of something.
Ma'am, can I try?
Doesn't it mean?
Yes. Someone
think-
said, can I try?
Yeah, ma'am. I think this function represents the given distance of the ship from the lighthouse.
Complete your sentence. It's missing. It does give the not from the okay. It does give the distance, right?
Yes, ma'am.
Of the ship from the lighthouse when what happens?
Now I'm lost, ma'am.
When it travels 20 kilometers parallel to the shore.
So then this gives a distance, listen to this, as a function of time. So meaning that from noon to, what's this? From noon, let's say after 1 o'clock, 2 o'clock, this actually gives you the function of the distance traveled after time t. Does it make sense?
No, ma'am.
Isn't that the expression gives us the distance the ship has traveled from the lighthouse?
Yes.
That's
At t is equals to 1, we don't know what's the distance. At t is equals to 5 hours, we don't know what the distance. At t is equals to 7 hours, we don't know what the distance is. Now this formula will help us to find that, because now it gives us the distance traveled from the lighthouse as a function of time.
Oh.
Yes.
So which means we can substitute any value of t, ma'am.
Yes, then it will tell you if, because we know, so meaning that if we substitute at t is equals to 20, remember this triangle will always be a right angle triangle. At t is equals to 20, then we know the distance from the lighthouse to the new point where the ship is. It will tell us the distance after 20 hours.
It makes sense, ma'am.
Don't rush to answer questions. Don't rush to answer questions.
Yes,
Okay,
but ma'am, word sounds. Oh, I don't know if it's the English or.
It's the English, but you need to make sure. So our drawing is not the same as theirs, but it's similar, right? So there it is. We first draw the picture. It's very important. And we did get this. Well done. And we did get this. Well done. Then we did the composition. Well done. And that's how we finished the section. Sure, it was a long section. Any question on this section?
Miss,
Yes.
can you please repeat example 5?
Example 5. Let me see. If it's long, I'm not. Okay, with example 5, they say that, okay, let's do this.
That's long.
So with example 5, you have f, g, and h of x. What you do first, you go and put, where you see h, you put x, which is this one over here. So that's x plus 3. You take this x plus 3, put it in g of x, like this. That's what they're saying, put inside. So this will be inside g of x, put x plus 3. Where's g of x? This one. Then you say x plus 3 to the power of 10. Then the last part says put this one inside of f. So this one is g of h of x. What is g of h of x? Is this one. Then, because there's x here, I put x plus 3 to the power of 10 divided by x. Where I see x, I put g of x plus, that's one, x plus 3 to the power of 10 plus 1. And that's example 5.
Okay, I understand now.
Danko. Okay, I'm stopping the recording. I don't know how many hours it is, but Sana. This was one long section.